These demos will be highly focused on programmatically deploying and configuring and managing Oracle Cloud infrastructure using managed infrastructure as a code offering. To tell you a bit about Dilli, Dilli is having a huge experience of working as Linux administrator as well as Oracle and MySQL database administrator. He is having experience of Oracle Cloud and Google Cloud. He also likes doing scripting, and he is having a good knowledge of shell scripting and Perl scripting. He has worked for many clients on-site as well as off-site, and he has worked with so many different versions of MySQL and Oracle databases because he has been in this field since 2002. So that is a huge experience to have on Linux administration as well as database administration. So without wasting much of the time, I would like to hand over the session to Dilli, and he would be talking about deploying Oracle Cloud infrastructure with Terraform. So welcome, Dilli, and thanks for your time and efforts for this particular session. Please take the control.
Thank you, Tejas. Thank you for your nice introduction and everything. So let's start sharing my screen. So are you able to see the screen?
Not yet, Dilli.
Let's drag this.
We can see your screen. We can see your screen now.
Oh, okay. Thank you for confirming. Okay, let's get some. Now you can see the slides, right? Can someone confirm it?
Yeah, we can see it.
Okay. First of all, thank you, SURATi, first for providing me the opportunity to speak on deploying Oracle Cloud infrastructure with Terraform. And hello, everyone. My name is Dilli Maharjan, and thank you so much for attending this session. And I hope you will enjoy this session. And on behalf of the SURATi, I would like to welcome everyone to this session. Okay, let's begin with few things about me. Okay, my name is Dilli Maharjan. I have started my IT career since 2002, and since 2006, I'm working as an Oracle database administrator. And these are my recent Oracle Cloud certification I have done. I have done Oracle Cloud Foundation, Oracle Cloud Infrastructure Architect Associates, and Oracle Cloud Architect Professional. And in addition to that, I have done this Google Cloud Engineer Associates, Architect Professional. And I have also done the HashiCorp Certified Terraform Associate also. So I'm certified on that. And in 2017, I have done Oracle Certified Masters on Oracle Database 11g. And last year, I was rewarded with the Oracle Ace from the Oracle Corporation. And I am proud to be the founder member of the Nepal Oracle User Group, Nepal OUG Oracle User Group community. And since 2018, I have been working as an Oracle database consultant for the Pythian group. And these are my social account links. So the first one is for the LinkedIn profile, and second one is Twitter handle, and the third and fourth one is the blog post where I do the blogging and do a posting. Okay, so let's begin about the contents of this session. So what we will going through in this session. So basically we will begin with the infrastructure as a code introduction. So in this part, we will focus on what the IAC, infrastructure as a code, is and why we need it. And after that, we will go to the Terraform introduction. We will go through the Terraform, what the Terraform is and why Terraform is needed. And later on, we will look after some of the Terraform elements It's a component or the elements that made up the Terraform configuration files. And after that, we have a demo where I will show the entire configuration, and we will build up a compute instance in an Oracle Cloud, and we will host a web server over there, and we will access it from the internet. And at the end, we will end up with the Q&A session. That's it. Okay, let's begin with what the infrastructure as code itself is. So basically, if I have to define the infrastructure as a code, so in a simple word, it's a maintaining the entire infrastructure in a configuration file. So let's say a decade back, so 10 years back, what we used to do, whenever we need to deploy some of the configurations, we need to install some servers, we will go to the market, collect this hardware and all this stuff. And that has changed a lot. So nowadays, with the use of the cloud, we just need to go through the cloud console. So whichever the provider is, either it's a AWS or OCI or GCP, we have a console access of the cloud provider, and we will go through the sum of the clicks, and we will get our infrastructure ready. So in this era, so infrastructure, what the role of infrastructure as a code is, it's basically managing the entire resource itself in a configuration files. So basically what we do is we write a code for the resource, whatever the resource we need, and those files are called the configuration files. And we need to follow the certain configuration language to write those configuration files. So if I have to take the example of the Terraform as the infrastructure as code. So in case of Terraform, we will use a HCL, HashiCorp configuration language, or we can use a JSON as a configuration language to configure those files. And so basically infrastructure as a code defines the desired resource, whatever the resource we are planning, whatever the resource we need, and how they are configured, what should be the state, what should be the configuration, what should be the setting of the resource. Everything is defined within the configuration file itself. And the best part is that it supports mostly all the providers, all the cloud providers like AWS, GCP, Azure, Docker, OCI, Alibaba. And if you are planning to use the infrastructure as code, then it will support the VMware and a lot of the providers. And basically, if I have to end up the infrastructure as a code definition, then it is the automation tool that is being used for the resource with the simple commands like a Terraform apply or some command like a Terraform apply. So basically, it is a automation tool that is being used to provision the resources. So once we have an idea what the infrastructure as code itself is, then the next stuff is that why we need it. So the main reason behind the infrastructure of code, the main reason behind using the infrastructure code is lifecycle management of our resources. So we can write whatever the infrastructure we need. We can write the desired resources in the configuration files, and we can simply provision. We can simply create them with the commands like a Terraform apply. And we work on it, and once we are done with working on it, so we need to destroy them, right? We need to delete all of them, and the deletion of the resources, whatever the resources we have provisioned, we have created, is pretty easy. So it's something like Terraform that destroy. So if we are using Terraform that destroy is a simple command to destroy. So for me, the main reason for using infrastructure as a code is a lifecycle management of the resources that is being deployed in the cloud. The next big reason I'm using infrastructure as code is it's maintainable and it has a correct number of resources. So everything is written within the configuration file. So we do not have to worry about the list of the resources that was provisioned last time. So if the code exists, then, and if we are using the correct configuration file, it will deploy all the resources we need. And it's very easy to maintainable, right? It's a text files, so it's very easy. The third main reason I prefer to use infrastructure as a code in my organization is it's a familiar tool for the entire team. So what we need is that we need a common set of tools that can be used by the entire team. And for the infrastructure as a code, it's very easy to learn and easy to adapt. And if I have to take the example of Terraform, it's very easy. I learned it very quickly. And it's very easy to learn and easy to use within the team. The fourth big reason is that the confidence in making changes. Let's say I have deployed a resource, deployed a compute instance with a very least hardware resource. Let's say I have a 2 CPU and just 8 GB of RAM. So if I need to upgrade it to 4 CPU and 16 GB of RAM, then I can easily modify in the configuration file. And once it is done, I just need to apply it. And it will update the resource as I have defined in the configuration file. And the last and not the least, the biggest reason for using infrastructure as a code in my organization is the version control support. So version controlling the resource seems a little bit exciting, right? Because with the version control, you have an idea what the previous resource, what the state of the previous resource, and what the current state of the resource that is being in the production, right? So with the use of version control, with the support of version control, we can keep track of the resource that is being used, the trend of the resource that is being either growing or we are decreasing the resource that is being used. So with the version control support, we can do a lot of things in the organization. Now, what the Terraform is. So Terraform is a product that is an infrastructure as a code that is being offered by the HashiCorp Corporation. So HashiCorp is the organization which maintains the Terraform. So the growth of the version of the newer version, they release the newer version very soon, and they are actively doing the changes. They are improving the Terraform code, the Terraform binary itself. So HashiCorp is the organization which owns the Terraform and which is maintaining the Terraform itself. And Terraform is a OCI IAC infrastructure as a code automation tool, and it is used in building, changing, and versioning the infrastructure in safely and efficient manner. Safely because whatever you write in the configuration file, it gets deployed without any issue, and very efficiently because it is quite easy to learn and quite handy to use. And Terraform used the configuration language. It has its own language with the name HashiCorp configuration language, HCL, and it also supports a JSON file. And if I have to define the workflow of Terraform, then we have the first thing we need to do is write the code. So whatever the resource we need to write the Terraform configuration file at first. And once we are done with writing the configuration, we need to plan it. So in this plan stage, this means whenever we execute Terraform plan, it will display all the list of resource that is being created when the Terraform apply is being executed. So you need to check with the output of the Terraform plan. And if you are satisfied with the list of the resources that is being created, the next step is Terraform apply. So in this step, all the resources we have defined in the configuration file will be provisioned, will be created. And the last step, once we are done with our job, once we are done with our tasks, we can always destroy, we can always remove those resources, because in cloud, if you left some of the resource without any use, then it will charge you, right? So it's a pay as go offering. So whenever we are done with our job, we like to destroy all the resource that is being provisioned. So the Terraform destroy is a simple command to destroy all the resources that we have created using the Terraform apply. The next thing is how we install Terraform. So Terraform supports all of the operating system. You can install Terraform for your Mac operating system, Windows, Linux, FreeBSD, OpenBSD, and even the Solaris. So the image, the image in the right, I have listed I have actually captured the screenshot of the download page itself, where I have selected the operating system as a Linux and the distribution. So the distribution I have chosen is the CentOS/RHEL, Red Hat Enterprise Linux. And within the Linux also, it supports Ubuntu, CentOS, Fedora, Amazon Linux, and Homebrew. So to sum up, it supports all the operating system and all the distribution within the operating system also. And the installation itself is pretty easy. So in case of Linux and CentOS, you just need to install, yum utils to download the repo and install it. And second thing is that we need to download the HashiCorp repo. Once it is done, we just need to execute yum-y install Terraform. So that's it. So it will install Terraform. The next stuff we need to learn, we need to know about is the configuration. So what the Terraform configuration files and configuration itself is. So basically, it's a set of the files that is used to describe the infrastructure, what the resources I need, and what are its state, what are the attributes and values for this resource. All these files, all these things are defined in the configuration file. And the configuration file is the declarative model for the defining infrastructure. So basically what we do is we declare the attribute and values for the resources and the infrastructure. And the configuration file contains most of the within the configuration file, a lot of things about, we define a lot of things about the resource with the settings and the values. And the language we can use for the configuration file is the HCL, HashiCorp configuration language, and or a JSON. And if we are using a HCL, HashiCorp configuration language, then we end up with the extension of the configuration file as .tf. And if we are using the JSON, then it's a .tf.json as an extension for the configuration files. Okay, so here is a screenshot I have captured with the list of the configuration files. So in this case, output.tf is the Terraform file, configuration file, where I have defined the output block over there. The second file is the providers.tf, where I have defined the providers information over there. That Terraform.tf state, tf state backup, these are the state files. We have a variable.tf, where I have defined the variables. Pythian.plan, this is the output of the plan command. And Pythian.tf is the Terraform configuration file for the Pythian. So we will go through all of these components in our next slide. Okay, the provider. So provider is a very important component, because that provider is the, you can say, the base component which defines which cloud provider or which named provider you are going to use for the configuration. So basically it supports cloud providers as AWS, OCI, Azure, GCP, Alibaba, and all. And even you can use Terraform for VMware and Docker. So if you are using the provider as a Docker, then we have to use the provider with the Docker. So basically the provider is a plugin which actually translate all our API interaction with the cloud service. So these are the APIs which will be used to interact with the cloud service. And it supports API from most of the cloud service. As I have already mentioned, AWS, OCI, Azure, GCP, and all. And the best part is that within the configuration, within the single configuration, we can define multiple provider blocks. let's say if I have to deploy one machine in AWS and another machine in OCI, then I can define two providers with the AWS and OCI in a same configuration file. So here is an example where I have defined. So always the provider block start with the keyword provider, then the name of the provider. So in this case, I'm using the OCI as my provider. So within the double quote, I have defined OCI. And after, within this opening and closing braces, I will define the list of attribute and values for my providers. Okay, let's see the example. So this is the screenshot for the provider.tf, where I have defined the provider keyword and the OCI as my provider. And these are the attributes and values. So I have to define that tenancy OCID, user OCID, fingerprint, and private key path, and the region value. And the words in the left is these are the variables I have been using for this attribute and values. So these are the variables. We will go through the variables in next slide. The core component, core element of the Terraform is the resource. So resource, basically the resource block defines a piece of the infrastructure, whatever the infrastructure we are planning to deploy. So let's say if I need to deploy a compute instance, then I first need to define the resource block, something like resource OCI core underscore instance. It should be the keyword while creating the compute instance. So it's a piece of the infrastructure that we define in the configuration file. And it could be the physical component as a compute instance, or the logical as a functions application itself also. And it always contains the two string after the resource keyword. So first is the resource type. So what the resource type we need to, what is the resource type, and what is the name of the resource. So in the example, I have begin with the resource keyword, and this is the resource type I need to provision, and this is the name of the resource. So basically what I'm trying to provision is, what I'm trying to create is the OCI core underscore BCN, and the name of the resource is the BCN one. And within this block, within this bracket, I will define all the list and attribute for this BCN. So again, this is the example of the VCN.tf, where I have defined the resource OCI core VCN, and the name of the VCN I have defined is the Terraform VCN. So within this block, I have defined the attributes and values for the VCN. So the VCN that I am going to create has a CIDR block of 10.0.0.0/16, and the DNS level is a Terraform VCN. Compartment ID that I'm going to use is defined in this variable. So this variable contains the compartment OCID, and the display name of the VCN is a Terraform VCN. So this is the way we define the resource block. The next important component of the Terraform is data. Read the value from the data source. Let's say if I need to fetch the name of the availability domain within some region, then I need to use a data block, because the availability domain is already over there, and I just can read the values. I cannot change and define the values over there. So basically, data block itself is used to read the value from a given data source, and it fetches value, data, or compute for the use within the configuration file. So basically, it can be used to fetch data outside of Terraform. So something that is already defined by Oracle, or we can even use a data block to fetch a value defined by another separate Terraform configuration file. So let's say if I have another block of Terraform code, and I need to read a value from another Terraform block, then I can use a data block. So again, here is the example of the data block. So then name of the type of the data block, and finally the name of the data block. So here I'm trying to fetch the availability domain name in my another configuration file. So that's why I defined the data block with the name OCI identity availability domain as a type and the AD as a data block name. So within that, I have set, I have provided the compartment ID. So which compartment ID I am trying to fetch the availability domain information, and the AD number. The BCNs over some of the configuration file outside the Terraform, another separate Terraform configuration, and I am using this block to get the information about the VCN for my configuration. Okay, next important component of the Terraform is the output. So basically, output is simply a written value that get printed. So let's say if you have created a compute instance, and at the end you need to know the public IP of the compute instance, then we will use a output block. So with the help of output block, we will print the public IP, private IP, whatever the attribute that the resource content, we can use to use output block to print that. And it always contains a label and label after the output keyword, and it always contains label and value at the while it prints. So here is the example of the output, the TF output block. So output VCN ID. So in this case, VCN ID is a label, and the value it contains is what value that it prints is the OCI core VCN, the Terraform VCN.id. So basically, it will print something like a VCN ID equals to then the OCID of the Terraform VCN OCID. So basically, it OCID of the Terraform VCN. So it will print that way. Now, the next important block is the provisioner block. So the provisioner, with the help of provisioner block, so basically it is the block of code that get executed once your resource get completed. This local exec, we can execute some command over the local machine from where you have executed the Terraform on laptop, then the local exec, the block of code laptop. And we have another block of code within the provisioner. So that is the remote exec. So the remote block of code that is defined within remote exec will get executed on the remote machine that you have created. Let's say, for example, if I need to store the public IP of the compute instance that I have created in my laptop, once it is done, then I need to execute local exec and fetch the IP address of the compute instance that is being created and echo or save it to my laptop. So in that case, I need to execute local exec. And for example, once my compute instance is created, I need to install some of the packages. So then at that time, I need to execute the remote exec. And I need to define the yum -y install MySQL, some command like that. And it get executed on the machine that has been just created. So once the machine is created, it will install MySQL and whatever the commands you have listed within the remote exec. So remote exec with the provisioner block, you have some of the, basically, it can be used as a configuration after the provisioning, after the creation has been done. So you can install any of the softwares, or you can do you can trigger some of the jobs once the machine get created. Next important element within the Terraform is the input variables. So basically, we use the variables within the configuration file, and this variable can be defined, the value for the variable can be assigned in multiple ways. So the first way we can use is using the variable block. So the this first example is for the variable, then the name of the variable, then we define type of the variable we are using, and the default value for this. Let's try with laser button. So the default value for this variable. So that means that if we do not assign a next value in the configuration itself, then by default the region variable contains us as1, us-as1-1 as a value for it. So this is the way we can define the variable, define and assign variable for it. The next option we can use is using it as a var option. So while executing Terraform apply command. So while executing Terraform apply, we provide the variable value using the -var option. So here we are executing Terraform apply -var equals to then the variable and the values within this double quote. So in this case, within the configuration file, wherever we have used this variable region, it will use the value as a us-as1-1. The next thing we can use for the Terraform input variables is the Terraform.tf files. So this is the default name of the files we can use if we want to assign a values within the Terraform configuration file. So if you are using Terraform.tf.vars, it will automatically read, and we can define the variable and value in this manner. And in addition to that, all the files that end with the name auto.terraform.tf get also included within the configuration, and we can define the value this way in those files also. So then we -var-file as an option to include our to include our variable file name. So in this case, we have a Terraform apply to my file one. So the my file one, I have defined all the values, variable and values within the my file one, and this is being read as a variable file for my configuration. So this is the fourth way we can use the variable for, and the next way we can use the input variable is from the environment variable itself. So the way we have to use is the export. We have to use tf_var_ as a keyword, and then the variable name and its values. Let's say if I have to assign a value for the region, then I have to use export tf_var_region equals to us-as1-1. The next option we can use is the interactive prompt. Let's say I have used the variable within the configuration file, but I have not assigned any of the value for it. Then whenever I execute a Terraform apply, it will prompt for it, because this region, let's say in this example, the region do not contains any value. I have not assigned any value for this region. That's why it prompt for the value while I execute the Terraform apply. Then dot and the name of the variable. So in this case, user OCID is a variable name, and I am calling its value using var.user_OCID. And in this case, region equals to var.region. So region is my variable. The next important stuff is the state file. So basically, state file, it is used for managing the infrastructure and the configuration. It keeps sync between the infrastructure itself and the configuration file, and it is used to map the real world configuration versus the local state file. And whenever we do a Terraform apply, you will get a Terraform.tf state binary file which contains all the state of the resource that has been locally on your computer, or we can also store it in the remote state file is used when we work on a team, right? So if I have a team of 5 members and everyone is working for the same resource and same configuration, Terraform configuration, then I need to store the state file in remote so that everyone get a same state file whenever they execute the command. So this is the block of code that I have used when I plan to store the Terraform.tf state in the OCI bucket. So this is the bucket location where I have used to store the Terraform state file. The most important element is a module. So the module itself is nothing more than a reusable block of codes, and it contains input variables, output values, and the resources that need to be created when someone uses this module. And it contains a multiple resource and used together, and it can be used with the module block. So we need to call it with the module and the name of the module. And it is very lightweight in nature and abstraction and can be nested. So if you want to use module within a module, you can use it. And it can be loaded from the locally. So if you have download the module in your machine, then you can use it. And even you can use it from the remote repo also. So let's say if I have created a one module and I have shared it in the local repo, then anyone can refer that module and use it. So basically this module is something like a function that we get to, let's say, in case of this, if anyone is aware of the C programming, then we used to include header files, right? So it's very similar to header files. So it's reusable and it can be reused within the configuration. Okay, so we will see some of the Terraform basic commands. So we have a Terraform init, Terraform validate, Terraform plan with the option to save our file. And we have a Terraform apply with the option to include the plan file, Terraform show, and Terraform destroy. Okay, so whenever you execute Terraform init, then its job is to download the plugin that you need in the configuration. So let's say if I have defined the provider OCI, then it will download the OCI plugin for me. The next command is Terraform validate. So Terraform validate checks for the syntax in your configuration file. If you have any issue in the Terraform config, if you have any syntax error in the configuration file, then it will prompt an error for you. It will display an error for you. So, and if you do not have, if your configuration is syntactically correct, then it will return something like success, the configuration is valid. Next stuff is the Terraform plan. So using this Terraform plan, we have an option to save the output of this plan also. And using this Terraform plan command, we can list the resource that is being created when we apply the Terraform apply command, when we execute Terraform apply command. So the outputs look something like this. Following stuff will be created. All the stuff with the plus sign are output is the one stuff will be added and nothing will be changed and nothing will be destroyed. And with this out option, you can save the output of this to Pythian.plant binary file. And the next step in our command is to apply Terraform execute Terraform apply. So with the Terraform apply, we can also define the name of the plan that has been saved earlier. So with Terraform apply, it will create the resource that is being defined in the configuration file. So whenever you execute Terraform apply, it will execute the creation command, and it will finally return the one stuff is added. And if you have an output block, then it will print something like this. So it is printing the OCID of the PCN that is being created. And so this is the output of Terraform show. So Terraform show will, this command is being executed after we create the resource in the cloud. So Terraform show will list out all the resource that is being created. So once we are done with everything, once we are done with our job, we can destroy the resource that is being created with the simply Terraform destroy command. So with the Terraform destroy, it will prompt, if you are sure, it will prompt to confirm the destroy, and you can also use a auto approve option if you do not want to get the prompt for the confirmation. So here is the Terraform destroy auto approve. So in this case, it will destroy at its own. And in the case above, it will prompt you to type yes before it gets destroyed. Okay, let's jump to the demo. So in demo, what we are going to do is we are going to create a VCN inside a VCN. So we are going to create a Terraform VCN. Inside a VCN, we are going to create two subnets, public subnets and private subnets. And after that, we will create an internet gateway so that we can access the compute that is going to create inside this public subnet. And we are going to create a web compute instance with the name web0, and we will install Apache over there and host some website over there. Okay, let's jump to the demo. So for demo, I have created one Docker container. Docker container ls. So I have created one Docker container with the TF demo. Let's start this Docker. Docker PS, Docker exec. Let's open two more terminals. Okay, all the Terraform configuration has been stored within this OCI demo. And I have created two directory over there. Auth for all the authentication related file I have stored over here. It is outside the deploy code itself. So for the security reason, I haven't put the authentication related file. It's a public and private key files within the deploy directory itself. So here are the configuration files. These all files that ends with the TF are the configuration files, and the TF state. This is the Terraform state file, and this one is the variable file that I have been used. So here, this is the variable, and this is the name of the variable, and this is the value for it. Okay, let's jump to the demo. So initially, it doesn't contains any directory with the name .terraform, right? So it doesn't contain any directory with the Terraform .terraform. Let's execute Terraform init. So basically, Terraform init will download the plugin that is required for this configuration. Once the init get complete, then we can see directory with the name .terraform being created, and within this Terraform directory, it stores the API that is being required to communicate with the OCI, with the cloud provider. Okay, that it has already downloaded and installed the OCI, that is version 4.5.8.0. And if you check the directory structure now, then you will notice that the .terraform directory is being created by this init command. So let's check this Terraform directory. It has a provider, registry, terraform.io, and HashiCorp. And within the HashiCorp, you will get the null directory and the OCI. And within this OCI directory, it contains all the API files that is being required to communicate to this OCI cloud provider. Okay, this is the plugin that is being used to communicate to the OCI. Okay, back to the deploy. Okay, so here I have a configuration file for, let's check here. Configuration file for all the variables has been initialized using this file. I have defined provider over here. So basically I'm using OCI, and within for the OCI provider, I have these attributes and values, and I have a configuration for the network. So within this network, I have defined the VCN name. So my VCN name is my VCN. This, and the gateway I have defined default route, and web security list I have defined the security list, and all this stuff. We will go through the configuration file later. So once the Terraform init is done, we will check the syntax using Terraform validate. Yeah, all the configuration is valid. So the next step is to Terraform plan. Either we can use -out to save it to something else. So basically, after executing this Terraform plan, whatever it is, means whatever the resource that is being created will be saved to this SURATi first out. Okay, so if you go through the output, then it will list all the stuff that is being created. So it starts with null remote XCC, that a route table will be created, and core instance web0 will be created with all these attributes and values, and internet gateway will be created, security list will be created, and subnet will be created. This is the private subnet, and this is the public subnet that will be created. And this is the VCN block, VCN that get created. So in total, 8 resource will be created, and nothing will be changed and nothing will be destroyed. Okay, next command is to just execute Terraform apply or Terraform apply SURATi first. So let's try with the Terraform apply first, how it looks. So it will prompt you to confirm. Just type yes to approve to create it. The next option is to use this plan output file. So this is the option we can use for. Okay, before executing this apply, let's check our let's check resources using this console. Compute instances, network, Pythian. Okay, right now I do not have any compute instance over it. So both the instance is in the terminated state. So there is nothing, no compute instance that is in my console right now. And if I check the network, seems a little bit slow. Right now, there is no VCN, virtual cloud network, created in my console right now in my account. Okay, let's execute it and see. So using the Terraform apply with the output file name, it will directly start creating the resource rather than prompting you and listing the resource that has been created. If you have noticed, then the VCN is already created just now. And if I refresh, yeah, the test instance is being provisioned. So it is in the provisioning state. So, yeah, it is still creating. Now, once the compute instance is created, it starts executing the remote exec. So basically, remote exec is a block of code that is being executed on the remote machine that is being created. So for that, it tried to connect to the machine that is being created. So the machine that is created has a public IP 140.238.226.93. So it tried to SSH it. And once it successfully connected to using SSH, then it will display message like a connected. It is still trying. Yeah, it's connected now. So now, whatever the command I have defined in the remote exec block, it will execute. So basically, I think let's check the code itself, right? Okay, so here is the block of code. So within this remote exec, what I have done is, first I have tossed file just, and the next command I have execute is yum install httpd. So basically it install the Apache package in the server. Then I have created one index page within this var www.html/index.html. Then I made a configuration change so that it listen to the Sorry for that. I think I get disconnected in the middle. Okay. Yeah, it will install the Apache and Apache tool, and once once the installation is done, then it will change the configuration file so that it can listen to all of the available network interface on port 80, and it will start Apache and enable it. And I did some firewall configuration so that I can access the page. Okay, so using this public IP, I can access the page that I have created. So the page contains, this is the index page. Yeah, here it is. So using this remote exec block, we can execute we can do some of the configuration once the resource get created. Okay, back to the slide. We have one more slide. Yeah. I think it's better to have. Okay, so we have a bunch of resources, a bunch of the documentation. We can access it to get the idea about the Terraform, to learn about the Terraform. So let's access the Terraform registry. Okay, so once you open this page, you have the option to browse the provider or browse the modules. So if we browse the providers, then we have a lot of providers over there. So these are the verified providers. We have up to 35 pages of it. So we can use a VMware, Docker, Kubernetes, everything, almost everything. And let's jump to the provider, Oracle Cloud Infrastructure. And within the Oracle Cloud Infrastructure, we have a documentation link. So you can, if you have any problem with the syntax and all this stuff, you can just jump to this documentation and you can check it. So let's say if I have some trouble with the OCI core instance, then just go to this page and you can check everything, whatever this is the example, and even the attributes and what are the possible values for them. So this is basically HashiCorp has a good bunch of the documentation and you can go through that. Okay, the next thing is that there are a lot of Terraform alternative in the market, and I have used Pulumi and the Ansible as a Terraform alternative in few of the stuffs, and they have Pulumi has a lot of advantage over the Terraform. You can use loops, conditions, and even the object-oriented is supported in the Pulumi. And while using Pulumi, you can use other programming language like Go, TextScript, JavaScript, and all. Python is also supported with the Pulumi. And the Ansible is a popular tool to configure the resources. And I have heard about the Jenkins and the Ceph, but I haven't used it yet. Okay, so these are the resources I have collected. I have used to prepare this slides, and at the end we have a Q&A, and thank you.
So thank you, Dilli, for such a nice presentation, and you have almost used up entire time that you had. But a good thing is that we haven't found any questions from the audience yet. So we can probably wrap this up at this point. So thank you once again for your effort and for your time and such a good presentation. We hope to be remain connected as in the current as well as the previous sessions of SURATi TechTalks. So I would like to invite you soon in our next TechTalks also. Okay. Bye for now.
Thank you, Tejas. Thank you, audience, for the opportunity. Bye, everyone.